Hello everyone. Welcome back to the channel. Have you ever wondered what is the most basic building block behind complex operational amplifiers used in analog circuits? Today, we are going to understand the single-stage operational amplifier, its circuit, working principle, voltage gain, advantages, limitations, and applications in a simple and clear way. If you are preparing for competitive exams like GATE, ISRO, ESE, or studying analog electronics, this topic is very important. So let's start step by step. Introduction. An operational amplifier, commonly called an op-amp, is a high-gain voltage amplifier. It amplifies the difference between two input signals. Unlike normal amplifiers that amplify a single input, an op-amp works on differential input, meaning it takes two inputs. Non-inverting input, Win plus. Inverting input, Win. The output depends on the difference between these two voltages. Now, a single-stage op-amp uses only one amplification stage. It is usually implemented using MOSFET Differential Amplifier or BJT Differential Amplifier. This is the simplest internal structure of an op-amp and forms the foundation of multistage op-amps. Basic block diagram. Now let's understand the basic blocks. A single-stage op-amp mainly consists of one keycap differential input stage. This is the heart of the circuit. It compares Win plus and Win and amplifies their difference. Two keycap active load. Instead of using normal resistors, active loads, like current mirrors, are used to increase gain. 3 keycap output terminal. This gives the amplified output voltage. 4 keycap biasing circuit. This ensures proper DC operating point and stable operation. So in simple words, input difference amplified given at output. Circuit diagram MOSFET based. Now let's move to the MOSFET based circuit. Main components include two MOSFETs forming a differential pair. Current mirror as active load. Constant current source. Power supply terminals VDD and VSS. How it is connected. The two MOSFETs receive Win plus and Win at their gates. Their sources are connected together and connected to a constant current source. At the drain side, a current mirror load converts the differential current into a single-ended output voltage. This configuration improves gain compared to simple resistive load. Working principle. Now let's understand how it works. Step 1. Input signals are applied at Win plus and Win. Step 2. If Win plus Win, the MOSFET connected to Win plus conducts more current. If Win plus, the other MOSFET conducts more. Step 3. The difference in current flows through the current mirror load. Step 4. This differential current is converted into output voltage. So finally, output voltage is proportional to the difference between Win plus and Win. Mathematically, Wout, Win plus Win. This is why it is called a differential amplifier. Voltage gain. Now let's discuss voltage gain. For a single-stage MOSFET op-amp, voltage gain of is equal to Gm times ρ, where Gm is equal to transconductance. ρ is equal to output resistance. What is Gm? It represents how effectively the transistor converts input voltage into output current. What is ρ? It is the output resistance of the transistor and load. So higher Gm and higher ρ means higher gain. However, since this is only one stage, gain is moderate compared to multi-stage op-amps. Advantages. Now let's see the advantages. Simple design. Low power consumption. Easy mathematical analysis. Suitable for low-frequency applications. Because it has fewer components, it is easy to understand and implement. This is why it is commonly taught first in analog electronics. Limitations. But every circuit has limitations. Limited voltage gain. Limited output swing. Not suitable for high-precision applications. Lower bandwidth compared to multi-stage op-amps. Since it has only one stage, it cannot provide very high gain. For high-performance systems, multi-stage op-amps are used. Applications. Even with limitations, it has important applications. Sensor signal amplification. Analog signal conditioning. Basic amplifier circuits. Low-power integrated circuits. It is widely used inside IC design as a building block. In fact, advanced op-amps internally start with this basic structure. Conclusion. Let's summarize. Single Stage Op-Amp is the basic building block of analog circuits. Uses differential amplifier configuration. Provides moderate gain. Has simple structure. Forms foundation for multi-stage op-amp design. If you understand this concept clearly, multi-stage op-amp design becomes much easier. If you found this video helpful, like, share, subscribe to the channel, and comment below if you want. Two-stage op-amp explanation. Frequency response analysis. CMOS op-amp design. ISRO gate important questions. Thank you for watching. See you in the next lecture.